Hello everyone. I'm very pleased today to talk to you about the meaning and the concept of the algorithm function. Well, let's start by a very simple assumption. If we have 2 multiplied by 2 multiplied by 2 multiplied by 2, and we have 2 power 4. We know that this is power. And if we suppose that this 2 power 4 equals y, okay? So we will do something new for us for introducing the algorithm function. We will put this simple log and put under the simple 2, which is what I'm gonna power it, 2 power 4. 2 power 4 equals y, or sorry, equals 4. So we have to log y to the base 2 equals 4. This is what is the meaning of the algorithm function in mathematics. And we know that the y here equals 16. So log 16 to the base 2 equals 4. Let's complete the log. So right now we're gonna generalize the rule by saying the log y, the log z to the power y equals x. That means, as we get here, y to power x to x equals z. Okay? Well, we sometimes see in the calculator or in any mathematical problem, we see the symbol of log only when I say log y equals z. What's the meaning of this without putting base here? Actually, the base which is hidden right now is 10. Be careful of this. This is the base 10, but in mathematics we delete this symbol to simplify it. So here 10 power z or z equals y. Okay? This is the base 10, which is hidden. Okay? Another thing for the logarithm function, we have something called e, which is exponential function y equals e to x. So if we take the log e y equals x, this is its meaning, okay? But we simplify log y to base e to become something called ln. Ln y equals x. Okay? This is the meaning of log y to base e. Okay, this is exponential functions. Let's see something different for the techniques of using logarithm in mathematical problems. This is technique of log. When I say log 10 equals 1, this is usual, and log 100 equals 2, because 10 power 2 equals 100, and so on. We can do this to become log 10 power 2 equals 2 log 10, which is actually 2 as well. So if I say log, this is a rule, okay? This is a rule. Log a, b, multiplication, product, equals log a plus log b. Yes, if I say log 10 multiplied by 2, for example, equals log 2 plus log 10. Yes, if we suppose that this is 20, okay? So if I say, and this is actually the base of 10, so 10 power y, suppose that this is equals y. 10 power y equals 20, so y equals log 20 to the base 10. Okay, this is what. Actually, I got it back again. So, what I want to say that this equals y, okay, which is log the same of here. So, let's move here and suppose that this is 10, the base. So, if I say that this is x, so x 10 to x equals 2, okay, and here we'll suppose that this equals z, and say this is the base, so 10 power z equals 10, and we know that that equals 1, so the result here is 1 first, and x here is the same of if I calculate the value of x and add it to 1, it actually equals y. This can be calculated by the calculator. Okay? This is a technique, and also there's something for the division. If I say log a over b, this equals log a minus log b. Yes. How? This is actually like the same way. If I say that this is log a multiplied by b power 1, which is the same, this equals log a plus log b minus 1. Actually, this will be transferred to become minus. So we will say log a minus log b. It's the same. Okay, so we're going to remove it and talk about something else. This is some techniques, but the problems are very lot to use the same techniques and another of different techniques. This formula, log AB equals ln B over ln A. Okay? Basically. Let's differentiate the function of log. Say log A firstly for the base 10 equals 1 over A. So one over because I differentiate for variable. So let's see. If I say that this d over dx log a, would you estimate the result is going to be 0 because you differentiate a constant. Okay. Or what if I want to integrate? Let's move to integrate. And before moving to integration, let's differentiate d over dx log a to x. It becomes 1 over x. You get the differentiation here multiplied by 1 over ln of the base. What if this was log a x squared? Because you get the differentiation of x squared, which is 1 over 2x. Okay? You get just 1 over x squared multiplied by 2x multiplied by 1 over ln A. Hope that this is right. Yes. Okay. Let's move to another. This is in brief to talk about the differentiation of the algorithm function. Let's move to how to integrate most of the integration, like to integrate ln x, for example. This is quite simple. We can integrate it by the definition of the integration by parts, which is to integrate u dv equals u v minus integration of v du. Let's apply the same here. We will suppose that this u equals ln x, for example, okay? And dv equals, this is actually ln x multiplied by 1, okay? So dv equals 1 dx. We take dx, 1 multiplied by dx will be dv, and we take the ln to become u, okay? Let's do it. So if I differentiate, integrate ln x multiplied by dx equals uv. So we have dv equals 1 multiplied by dx. So if I integrate dv over dx, I will divide dx, dv by dx, and 1 over dx by dx equals integration of 1 dx. So integrate dv equals v equals x plus c. But here we will neglect the c. It will just be x. Okay. uv becomes ln x. So x ln x minus integration of v du. We now have du equals, you know that the differentiation of ln x 1 over x dx. Okay, so it becomes 1 over x multiplied by v, which is x dx. So right now we have the differentiation, the integration of ln x equals dx equals x ln x minus the integration of 1 dx, which is x, plus c. Okay? This constant will be important because we must not forget how to put the constant after the integration. Basically, this is integration of the exponential function ln x. Okay? So we have given a threshold of the technique and the meaning or the concept of the algorithmic function and some of the exponential function. Someone can ask, well, how we could benefit from this? If we see the programming and the computer analysis inside the programming, we're going to see sets of methods. This is the algorithm. If you check the dictionary and know about the meaning of the algorithm, you're going to get the definition of the systematically put ways, systematically formulated ways. For example, I will give a funny or just a good example. If I'm right now at home and I want to go to Cairo, for example. My home is in Alex and this is Cairo. So I will not go from home to Cairo directly, so I must get it systematically. From home, I will go to the station by bus, for example. And from the station, I will take the train to another station. I get it systematically, way by way, too. Then, after getting the station, I will take a taxi to another station, taxi to station 3, and then I will get the train again. This, for example, just example, to Cairo. So this is systematically formulated ways. This is just ways. What I want to say here is that the meaning or the system you follow to get to the problem or to get to the targets. This is the algorithm. We follow the algorithmic functions. We follow the programming like Python. If we talk about Python or we talk about the JavaScript. All of these include mathematics, include exponential functions, include